Okay, today we will look at summarizing and analyzing data. This is a new topic recently introduced by ACCA. This topic also appears in paper P4, Advanced Financial Management. Not the whole thing, but this is kind of foundation for the topics in P4. The table that is given in this chapter will be given in paper P4 as well. Okay, so what we are going to do in this chapter is just read through the book and look at the questions that has been answered in the book. And then for practice, we will look at kit questions. Okay, let's continue. First thing we have is group data. You should already know the difference between data and information. So group data is data that has been organized into groups. Like we have example here, 700 to 799, it is a group, a class, a range. So this is group data. Ungroup data is data which has not been organized into groups, like individual units given here. Then we have discrete data. Discrete data is data that has a specific limit and it is countable. A good example of this would be, let's say, ACCA score. So you know where your ACCA score is going to be. It will be somewhere from 0 up to 100. And it is countable. And it is not in points. So discrete data is not in points. Because if data is in points, then it can be many variables. On the other hand, continuous data is data that doesn't usually have a specific range, and it is not usually a whole number. It can be in points. An example of this would be, let's say, weather. So weather of an area can be anything. There isn't any specific limit. Then we have frequency. Frequency means frequent. How frequent is a variable in a data? How many times something appears? Like we have data here. If we look at 70, we have once, twice, thrice, 4 times, 5 times. So we have 75 times. This is called frequency. So we have other data as well that appears. For example, we have 69, which is once and twice and thrice. So this is called frequency. Like they have shown here, 65 appears once, 66 appears 0 times, 67 appears twice. We have 67 and 67. So total frequency is 20, which means total data. So here the total data is 20. And then how many times each individual data appears is frequency. If instead of looking at each individual items, what we could also do is put them in groups like we previously did here and say how many times units in a range appear. That would be frequency. Units from 70 to 700 to 799 is once, any unit that there is. From 800 to 899, we have one frequency. From 900 to 999, we have 2. From 1000 to 199, we have 5. And here we have 7. So we have the highest frequency here. So data mostly appears in this range. This is frequency for discrete data, which has a specific range, a limit, and then we can have frequency for continuous data as well. The way classes are designed in continuous data is a little bit different. If we look at discrete data, we have 700 up to 799, and the next one is 800 to 899. If you look here, up to and including 154, it means it would be starting from 0 up to 154, up to and including. And the next one starts from 154, but it says over. It doesn't start from 155. It starts from 154 over. What it means is that if our data is 154 point something, it will come here. If it is exactly 154, it will come here. So we don't do that with discrete data because it is not expressed in points. So if I say up to 154 and then over 155, it would not be correct because anything that comes in between 154 to 155 in points, that would not be shown in any range. So we say including 154, then the next one is over, and the same continues. And then anything above, because it doesn't end. Next we have cumulative frequency. The easiest way to explain it is, like if we look at the lowest number here, the highest number, 74. Let's take 75. If I say how many times units are there below 75, it would be 20 times, because all units come in that range. This is called cumulative frequency. If I say how many units are below 73, then these two would be removed. It would be 18 times. So which is shown here as well. For example, unit equal to or less than 700 is 20 times, because all of the data in the example above is below 700. And below 800, sorry, this is not below, this is above. Equal to or above 700, because the data here we have, all of it is above 700. And then equal to or above 800, we have 19, because we have some data which is 792 as well, which would be below. So this cumulative frequency decreases. You could look at it like this, or you could say units that are below 800, or units that are below 700, then it would start from 0. Units that are below 900 would be 2 times. Units that are below 1300, we have 20 times. So you could look at it like this, or you could look at it like this. Okay, so we saw what is frequency, what is group frequency for discrete variables, and then continuous, and then cumulative distribution. Now this cumulative frequency can be expressed on graphs as well, called ogives, like in our previous example, or a new example here. We have data above 0 and equal to or less than 1. We have 5 times, and then 1 up to 2, we have 5 times. Cumulative frequency total is 14. So the way it would be represented on the graph is, we have units up to 1 units. Number of rejected units, we have 5. Inspection, if more units are inspected, this frequency will increase. So it is added to the top of that. So it becomes 3, it becomes 4. So as the units are increasing, cumulative frequency is increasing as well. Okay, moving forward, we can put frequencies on histograms as well. The individual frequencies that we saw, not the cumulative. Like we have from 7 to 800 units, 1 times, here is the frequency. From 800 to 900 units, we have the same thing. 900 to 1000, we have 2 times, consistent with this data. Sometimes what happens is, this group that we have created, it might not be equal intervals. For example, every group here is about 99 or 100 if it starts from 700. So every group interval here is 100, so no problem there. But if frequency of groups is not equal, then histograms would not give correct picture. Like we have data here, we have 60 to 80, we have $20 interval, then we have 10 interval, then we have $30 interval, and then we have more than 120, the way where we don't have any interval at all. So if we represent it the same way, it would not be consistent. So what we do is, if range of data is smaller, the width of these bars should be smaller, like represented here. So this is a smaller range. Smaller range will have smaller width, but that would be compensated with a higher frequency. We call it frequency density. So if we have, let's say, a day in this example, we have 700 to 800 and 800 to 900. We have 1 frequency for both. Let's assume that this was 700 to 800 and this was 800 to 850. Then this bar would be half, and the length of it would be, the height of it would be double. So what we do when we don't have equal intervals, the first thing we do is we find a standard width. Standard width would be width that is common in all of the ranges. Like in some ranges we have here, it was 20, here we have 10, here we have 30. So none of them is repeated. So it could be either 10, it could be either 20, it could be either 30, but 20 kind of comes in the middle of 10 or 30. So 20 would be a good range. If anything that repeats more than once, we would select that as standard width. But here in this example, none of the range is more than once. So we would select 2 as our common width. So what we will do, based on that width, we will increase or decrease the frequency. The width remains the same. If it is 100, it should be 100. If it is 50, it would be half. If it is 150, it would be a bit wider. So there is no problem there. So the problem is we change the frequency depending on the width. If width is smaller, We increase the frequency, it means it will become taller. If width is larger, we will decrease the frequency. Like in this example, if we select 20 as our common, we will select the 20 frequency as common. Anything that has higher width, its frequency will decrease. Anything that has lower length, its frequency will increase. And we do another thing as well. We have to close this as well, because we can't have a bar which doesn't have any end. So we need to close this. Okay, so they've already done calculation here, so you look at that. But if we take one of them common, I will just explain that. Let's say a 20 is considered as common, which is here. If arranged that is from 80 to 10, it is 10. It has 10 range. What is the common range? Common range is 20. So what we do is we take its frequency, we take 20 divided by the range, multiply by 6. So its frequency becomes 12. So it becomes taller. If we look at this one, which has 30, so we will take that 20 divided by the 30, multiply by its frequency is 6. So it will become a little bit lower. So anything that has wider width, its frequency will decrease. Anything that has shorter width, its frequency will increase. So it is done here. So we have this one frequency of 12, and this other one frequency has decreased to 4. So this kind of represents data a little bit better, because if this was not taller, it was only 6, it would not be very fair, because the range is very smaller. So we have to give it kind of a credit. And then we call this frequency density. Okay, we have a question here. In a histogram, in which class interval is 1/2 in times as wide as the remaining classes? It means it is wider. If it is wider, then its frequency would be lower. The height to be plotted in relation to the frequency for that classes. So it is 1/2 times larger. So if 1 is normal, it is 1.5 times, then its it would be 66% taller. It would be a little bit shorter. Okay, next we have averages. We have something called mean, or arithmetic mean, which simply means average. How do you find average? You add all the data that you have and you divide it by total number of units, or whatever total activity is. So this is individual. And then if they are given in frequencies, how many times, because they are grouped, how many times something appears, then we have to multiply by frequency. Because if we have 2 times 3, we have to multiply by 2 to calculate total. So then we take total and divide by total units. Because these individuals are not total, because if I say I have 20 data and I have 30 and I have 10, if I add all of them, it becomes 140, and the data that I've taken is from about 7. So divided by 7 would give me 20 average. But if data is represented like this, 20 is 3 times, 30 is 2 times, and then 10 is 2 times. So obviously we have to multiply by the frequency. This becomes 60, this becomes 60, and then this becomes 20. So 120 plus 20, same 140 divided by 70. So this is basic average. So formula is also given, which is frequency divided by units. Okay. What if data is not given individually like this? If it is given in groups, like here we have frequency from 0 to 5, we have 4 times, from 5 to 10 we have 8 times, from 10 to 15 we have 6 times. So some data, for example, here could be 1, some could be 2, some could be 3, but we don't go into that much detail. So what we do is we find the midpoint. Like here, midpoint is 3, here midpoint is 8, here midpoint is 30, here midpoint is 18. And then we multiply by the frequency, and then total divided by units would give us exact same thing like the previous one. Obviously, there will be small difference because midpoint is not exact number, but it will make things a little bit faster. Okay, then they have given you a question to find x. Look at it, do it. They've already answered it here. Okay, next we have mode or model. Model value is an average, which means most frequently occurring value. Like we have demand units, we have 6 units, which happens 3 times, 7 units happens 6 times, 8 units happens 1 time. So 7 is the most frequently happening, so it is the mode. It can be represented on histogram as well, bar charts as well. So the one that is the highest is the one that most frequently happens. So it will be the mode, which is between 20 and 30 here. If you want to find exact value, then you find the midpoint. You take one corner, you meet it here, you take another corner, and you take and go to the bottom, you have the middle. Okay, next we have median. Median is not average, it is the middle unit. For example, I have data, I have 1, 3, 4, 6, 8, 11, 12, 15, 16, it becomes 1, 2, 3, let's put commas. If I add all of them together, 1 plus 3 plus 4 plus 6 plus 8 plus 11 plus 12 plus 15 plus 16 becomes 76. And number of data is 1, 2, 3, 4, 5, 6, 7, 8, 9. 76 divided by 9, we have average 8.5. But median is the middle value. Like if I've taken this data from 9 pair of data, then 5th one would be in the middle. So in here, we have 5, 4 on this side, and then 4 on this side. So the 5th value, which is 8, is the median. So 8th value is the median. So median is the central value. Like in this example, where 8, 6, 9, 12, 15, 6, 3, 20, 11. Obviously, you have to arrange it in orders. So if you look at the pair of data, we have 3, 6, and 9. Same thing, we have the middle value, which is the 9th one. Okay, in this example as well, find it is 21. If you look at it, arrange all of them in orders, you will see that it is 21. This relates to the previous question here. They've repeated it. They just copied, pasted in the book, I believe. So the answer of that came here as well. So don't be confused about this part. This is just answer of the previous question. Okay, how do we find center point when we have group data, which is given in frequencies? Like we have 8, 12, 16, 17, 19. Obviously, the median would be 16. But it is not the whole data. It is given in terms of frequency. So it becomes about total 35. So any value in between that, in between 35 would be your answer. If you take 35 divided by 2, it will give you a midpoint. If, for example, in our previous example, we had 9 and we take it divided by 2, it becomes 4.5. But if I take 9 and I add 1 to it, you do this with odd numbers. So if you divide by 2, it gives you this fifth. So the fifth number would be your middle. So if we take 35, if we take 35 plus 1, so you are just adding 1 to it, so that it gives you one value higher than the mid. Because it doesn't give you half unit, it gives you full. So divided by 2 would give you 18th unit would be your midpoint. If you see here, we have 3 cumulative frequency, and then when we look at 7, cumulatively it becomes 10, and then if we add this 12, it becomes 22. So we know that 22 frequency is with 16, so 16 is our median. If I write it like this, 8, 8, 8, and then 12, 12, 12, 12, 12. And if you go on like that, the 18th number would be 16, because we know that from our frequency. Obviously, if this frequency is arranged in the right order, so you should start from lower to the higher. So median is that middle value. It is not average. Remember that. We can put it on the graph as well. For example, if we have group data, we have from 340 to 370, and the total data is 40. So it is odd number. In odd number, we don't have to divide it by, we don't have to add 1. We just divide it by 2 directly. It becomes 20. So 20th would be our midpoint. Okay, so we have, obviously you have to start from lower to higher. So we have 340, 370, we have 17 here, and 370 to 400, we have 9 here. We have another 9, 3, and 2. So they have been put on the graph with the frequency. We have 17 here, 370, 40, another is added. Collectively, it becomes 26. 430 collectively becomes 35. So if you want to find the median, which is the 20th, whichever value is here, which is between 370 and 400, that is your median, which approximately becomes 340, because 380, it is a little bit higher than 70. It is in the middle of 370 and 40, but if you want to be a little bit exact, it becomes about 370. You can find it like this as well. So we have 26 frequency, and this 26 frequency lies here, so value would be in between that. Okay, this is one part. Next part we will do in another video.